The last set of identities we're going to look at in this unit are the product to sum identities and the sum to product identities. So these are actually pretty simple, especially compared to everything else that we've done so far this unit. So we're going to start off with the product to sum identities, which are right up here at the top. All right. And basically what these are going to let us do is take a product of either a sine or a cosine and change it into a sum or a difference of a sine or a cosine. So let's go ahead and take a look at a few examples of how to use these. All right, and once again, these will all be provided for you on the test, so don't worry about having to memorize them. All right, so to start with, we want to express each product as a sum containing only sines or cosines. So our first example, we have cosine of 4 theta times the cosine of 2 theta. So we have a product of two cosines, which matches this middle formula right here, cosine of alpha times cosine of beta. So the first thing I'm going to do is I'm just going to label my angles as alpha and beta. So 4 theta is going to be alpha, 2 theta is going to be beta. All right, so my cosine of 4 theta, cosine of 2 theta, if I just substitute this into my formula here, we'll have 1/2 and then times cosine of 4 theta minus 2 theta plus cosine of 4 theta plus 2 theta. All right, so then we just need to simplify, combine like terms. So this will be 1/2 times the cosine of 2 theta plus the cosine of 6 theta. Okay, so looking back at what we wanted to do is that express each product as a sum containing only sines and cosines. We went from a product, we now have a sum. That's our final answer. That's all we were trying to do, is just rewrite our product as a sum. Okay. All right, so similarly for example 1b here, we have sine of 3 theta times sine of 5 theta. So this time we have a product of two sines. So we're going to be using this top formula right here. I am going to label my angles again as alpha and beta. So 3 theta is alpha, 5 theta is beta. I'm just going to plug it in. So this is going to be 1/2 times the cosine of 3 theta minus 5 theta minus the cosine of 3 theta plus 5 theta. Combine my like terms. So 1/2 times the quantity cosine of negative 2 theta minus the cosine of 8 theta. Okay. All right, now there's one extra thing that I want to do on this example that we didn't have to on part A. And what I'm looking at here is this first term, we have a cosine of negative 2 theta. So we're never going to want to leave our answers on these with a negative angle inside of it. Instead, we're going to want to remember our even odd properties in order to rewrite any negative angles as a positive angle. So if you remember back to your even odd properties, and this was way back in Unit 1, we know that cosine of negative theta is equal to cosine of positive theta because it is an even function. So we can just change that cosine of negative 2 theta to cosine of positive 2 theta because it is an even function. Okay. And if it were a sine function, just remember that sine is an odd function. So sine of negative theta is equal to negative sine of positive theta. So in any case where you have a negative angle on these, just use your even odd properties in order to rewrite them as a positive angle. So once you change that to a positive angle, this is our final answer. Okay. All right, now we can also use these for actual numbers. So in this next one, we are looking at evaluating the cosine of 285 times the cosine of 195. And we're again using these same identities to do this. So we have a cosine times a cosine. we're using this middle identity right here. So I'm going to call these angles my alpha and my beta. So 285 is my alpha, 195 is my beta. And I'm simply going to plug them into the identity just like we did before. This is going to be 1/2 times the cosine of 285 minus 195 plus the cosine of 285 plus 195. Okay. All right, so then just combine our like terms again. So we'll have 1/2 times the quantity cosine of 90 degrees plus the cosine of 480 degrees. Okay. All right, so 90 and 480, these are all unit circle angles, so we can just evaluate our cosine at these values. So cosine of 90 degrees up at the top of our circle is 0. Now 480 degrees, this is of course more than a complete rotation around our circle. So just think if you subtract 360 from it, 480 is coterminal with 120. So cosine of 120 degrees is negative 1/2. Okay. All right, so then just simplifying this, 1/2 times negative 1/2 would give us negative 1/4 as our final answer. Okay. Okay, so that's pretty much all there is to these product to sum identities.